All right, so in this video, we'll continue taking a look at an example here now of integrating with substitutions. So this one's presented to us in a more, I guess, traditional way where we would want to integrate this, but we're going to make a substitution to make it easier. Now, I'm going to go ahead and give you this bit of information. I'm going to say let u equal 2x minus y over 2 and v equal y over 2. Now, if you're not seeing that, that's perfectly fine. For these types of problems, you can pick a variety of things many times, but in this case, they're being given to us. It's a good fit here, and it's a good fit here and here. But let's see where it takes us. And so if we go ahead and say that u equals this and v equals this, my next step, it's going to be a little out of order from the last problem, but my next step is to now come up with x and y in terms of u and v. And you'll see why I need to do that first. So from here, I can say that y equals 2v. And then if I take this y value and I plug it in right there, that's going to give me a u equals 2x minus 2v over 2. Or in other words, an x equals u plus v. So these are important to have. Not only are we going to substitute them in up here in a little bit, but these are what's going to allow us now to come up with our actual bounds. So, for example, if I come back up here now and I look at these bounds, we know these are x's, so this would be an x equals y over 2 plus 1 and an x equals y over 2. If I take x to equal y over 2, I also now know that x equals u plus v, and I know that y equals 2v. If I plug the 2v in right there, then u plus v equals v. In other words, u equals 0. So I went ahead and I've done this one. Let's do this one now. Let's say that x equals y over 2 plus 1. Then our u plus v would equal 2v over 2 plus 1. So we've got the u plus v equals 2v over 2 plus 1. So u plus v equals v plus 1. In other words, u equals 1. Now we'll move over to these. These are going to be y's. Y equals 0 and y equals 4. If we do y equals 4, we know that y equals 2v. So 2v equals 4, therefore v equals 2. Similarly, if we let y equals 0 from this guy, then 2v equals 0 and v equals 0. So there sits our bounds. Now, the final thing that we have to do before getting this set up is go ahead and compute the Jacobian. So j of uv. And this one's going to be easier than the last one because the derivatives of these are much easier. So partial x partial u would be 1. Partial x partial v would be 1. Then down here we've got partial y with respect to u. That's nothing. And then partial y with respect to v would be 2 in that last entry. And so computing this, you get a 2. That's pretty simple. 1 times 2 is 2, minus 0 gives us the 2. So for the final setup then, we're going to have a double integral. This one having a function here, remember we can't have x's and y's, so we're going to have to substitute this in for x and this in for y. That'll be a 2 times u plus v minus a 2v all over 2 multiplied by the Jacobian. And then since these are all constants again, it doesn't matter the order, so I'll go du dv. And if that's the case, we've got a 0 to 1 and a 0 to 2. So that would be our setup for this one, which hopefully makes it a little bit easier than the original. All right, so the last thing I want to mention here is the Jacobian for 3 variables. You can see it's got essentially the same setup here. The important thing to remember is that you would be going from the 3 variables of x, y, z into the u, the v, and the w. And so partial of x is on top with respect to u, v, w. with respect to parcel of y on top, our middle, and then UVW, and then Z UVW. So the setup is very similar. The reason I want to mention this, though, isn't because we're going to necessarily work a triple integral here, but it's more to point you in the direction of page 945 of your text. That's going to be helpful on the upcoming quiz, and it's also going to shed some light in on that distortion factor for polar, cylindrical, and spherical coordinates. So take a look at that. I think you guys will get a lot out of it. It's pretty easy to follow, and I really think it's going to be helpful on the upcoming quiz as well.